back. So as we were saying, the importance of the thromboplastin complex cannot be overemphasized. Why? Because the formation of this thromboplastin complex together with the activated factor number 10 plays a very important role in the conversion of the prothrombin to thrombin. The thrombin, on the other hand, it brings about the conversion of fibrinogen to fibrin. But how does that happen? How does that happen? What happened is that the thrombin, it hydrolyzes the peptide bond which are found between the fibrinogen. When it hydrolyzes the peptide bond which are found between the fibrinogen, it leads to the release of what is called fibrinopeptide. And this particular fibrinopeptide, it could be either fibrinopeptide A or fibrinopeptide B. When that happens, it now gives the room or provide the opportunity for the occurrence of polymerization between the fibrinogen. And once there is polymerization of the fibrinogen molecules, we now get a fibrin. So in essence, a fibrin is formed by the polymerization of fibrinogen. It simply means that a fibrin is formed when by the combination of different molecules of fibrinogen, which is called polymerization. Okay, now this particular fibrin plays a very important role in strengthening the primary hemostatic plug that we have formed initially. That's the platelet plug formation that we've talked about initially. What it does is that it strengthens by reinforcing this particular plug with the fibrin mesh. Now this particular fibrin mesh is formed by the cross-linking of the different ends of the fibrin around the primary hemostatic plug. And there is the 13th blood coagulation factor, which is called the fibrin stabilizing factor. The fibrin stabilizing factor, alongside with calcium, plays a very, very important role in this cross-linking that we've talked about. You can also call it you call that clot retraction. Alright, having understood how the body forms a clot, the primary clot, how the body strengthens this particular primary clot through the coagulation cascade, otherwise you can call it the secondary hemostatic plug. Now we are going to understand how the body handles this particular hemostatic plug when it is no longer needed by the body. And the pathways that are involved in taking care of these unwanted plugs is called the fibrinolytic pathways or clot dissolution pathways. Now, these particular fibrinolytic pathways, they are complex of biological processes which lead to the degradation of the fibrin. This particular degradation of the fibrin is very, very important, because once we have a persistent thrombus or a fibrin or a thrombus, you can just call it a thrombus for our conveniences. Once you have a persistent thrombus, it can lead to the dislodgement of this particular thrombus from the site of our primary action. When this particular thrombus has dislodged, it can go and lodge into a small caliber vessel. And when that particular thrombus is moving inside the blood vessels, we call it an emboli. But because it's a thrombus, that's why we call it a thromboemboli. That means a persistent thrombus can lead to the formation of a thromboembolism. Alright, now when thromboembolism happens due to the lodgement of this particular thrombus in a small caliber vessel, it can lead to what? To the occlusion of that particular vessel. And when a vessel that supply a particular region of the body is occluded, it can lead to what? The development of ischemic condition on the respective part where that particular vessel supply. And when that happens, there could be a lot of complications that can follow. A lot. Necrosis can kick off. A lot of anaerobic process can take place, which could eventually lead to the development of what? Acidosis, which is not a very, very convenient scenario for the human body. So that's why you agree with me that what? The degradation of this particular what? Clot which are formed is very, very important. So right now, having understand how the body forms a clot and how the body takes care of the clot when the services of those particular clots are no longer required. Now we are going to go into the disorders that affect all this process we talked about. We're going to go into the disorders that affect either the coagulation pathways, in which what happens when one of the factors is missing. We're going to go into the disorders that affect the functionalities of the platelet. And then we're going to discuss a very unique type of pathology called the intravascular disseminated intravascular coagulation, or you can call it disseminated intravascular coagulopathy. All these things is what you should look out for in the next segment of this particular lecture. For now, I remain Ruben Gombalandi from Webzmedlectures. Thank you very much. Click the like buttons and subscribe. See you in the next segment.